All right, everybody. Sorry I couldn't be there in class today. This is the second to last gas law. So if you're wondering when the madness was going to end, it's coming. Dalton's law of partial pressures. I kind of call this the no-duh law. It's pretty easy once you kind of understand it. And it's almost like one of those, did they really need to make a law for this? But they went ahead and did it anyway because it comes up a lot, actually, and we're going to be using it in a lab that we're going to do sometime next week, if not the week after. So we're going to talk a lot about partial pressures. And so when you have a mixture of gases, we're going to call the partial pressure the pressure of an individual gas. It's the pressure that just that gas would exert by itself. It's part of the whole. Now, Dalton's law states that the total pressure of a mixture of gases is equal to the sum of the partial pressures of each one. Here's the equation. Now, the reason that you have the equation with the dot, dot, dot down here is that however many gases you have in the mixture, you would just keep adding P4, P5, P6, and so forth. Total pressure is equal to the sum of all of the individual partial pressures. Here's what that might look like visually. If I have hydrogen gas with a pressure of 2.4 atmospheres, I have helium gas with a pressure of 6.0 atmospheres. The total pressure, if I were to mix those two gases, all conditions otherwise the same, would be 8.4, which, yes, that's those two added together. So yeah, total equal to the sum of the partials. Here's another example. 2 plus 1 plus 3 equals 6 when you add them all together. So the green ones, the orange ones, the blue ones, individually, 2 atmospheres, 1 atmosphere, 3 atmospheres, all together, same container, 6. Now, when does that come into play for us? This is where we oftentimes, when we do chemical reactions where we're trying to recover a gas, will do so by bubbling it through water. The reason we do that is because we can put water into something like a graduated cylinder, and we can invert that, and the water stays through the magic of atmospheric pressure, and we run a tube up inside there, bubble the gas inside that tube, and the gas displaces the water. We can then use that to measure the volume of the gas. If we know the volume and lots of other things, we can figure out other information about that gas. So oftentimes that's how we're going to do that. Now, here's the thing. In this particular case, we were producing oxygen gas. That oxygen gas is collected inside of this little container here. It's not the only gas that's in there. Anytime you have gas in a closed container that also has water in it, a certain amount of that water is going to evaporate, and you're going to have a mixture of whatever gas you've collected plus water vapor. If I wanted to know just the pressure of the gas that's in there, I have to subtract the vapor pressure from the water, from the atmospheric pressure, which is pushing on the outside of this. So it turns out that the total pressure in here is equal to the total pressure out here, and we call that pressure atmospheric pressure. So we subtract pressure of the water vapor from atmospheric pressure, and that gives us the pressure of just the oxygen gas inside. I'll give an example here right now. So if we use that example and we actually had some numbers, we figured out that the vapor pressure, which is dependent upon temperature, was 23.0 kilopascals. The atmospheric pressure that was pushing on the water outside was 98.5 kilopascals. What was the pressure of the oxygen gas? Well, I'm just going to subtract those two. If the oxygen gas plus the water vapor equals 98.5, then 98.5 minus 23 would give me the pressure of the oxygen gas. So I just have to do a little subtraction action there, and that's how that would work. So super simple. You have a little sheet that you're working on that this is linked in that has about 3 questions on it, in addition to the notes that you hopefully took on that sheet while you're watching the screencast. So good luck.